Hi everyone, in this video I would do my best to show you just a few experiments I make with a space-time antenna and probably to ask you for advice because I'm not electrician or engineer, but I found it very interesting. The first thing I make is that I have two very powerful magnets and I approach them very slowly to see that there is no electromagnetic flux, so there is no electricity, and when I'm doing it a bit faster, because it's moving the probe inside, this creates electromagnetic flux and thus then induce small current, small electricity. Electrons start to move. This is known as Faraday's law. Michael Faraday discovered that when we move inside the magnets, we create electromagnetic flux, and thus then this became electricity. So this is a coil that is made out of the same copper wire that I make the space-time antenna. It's just left over. I'm not sure how long is the wire, but one probe now you can see the red one is nowhere, it's not attached, and the black one, the minus, is indicating almost zero. What I'm going to do now is I'm going to charge this coil with a Tesla tower. I'm going to apply a bit of electrons inside. You can see the power meter start to move. The both probes now, they are not attached nowhere. They are simply not attached, but they indicate because the Tesla tower shooting like a random rate discharge electrons in the air. So those two probes just detect different very random current. You can see it's a very small charge, but the power meter is working and it's very accurate. Now you can see I'm going to touch it. You saw the initial charge and there is still some electrons. This is something like static electricity. I touch it 2-3 times and now you can see that at the end, you see there is still electricity moving inside. It's 1, it's 2, it's 3, about 4. I touch it again and it's again about 2, 1. There is still some electrons probably circulating inside. So they create a bit more from the magnets. Well, the next thing we're going to do is to measure the space-time antenna. As you can see here, the both probes are nowhere, they are not attached, and I'm just applying the Tesla tower to charge, to initially to kickstart it. I believe that this electricity it's not enough to create the initial impulse. I'm not even sure if the space-time antenna it's absolutely built the way it's supposed to be, but well, I'm doing my best to see. So you can see that with the Tesla tower we just kickstart antenna, we apply it just to transfer some of the electricity, some of the electrons, and now we're going to make a measurement. Again, the red probe is not touched. You can see there is no attached at all to the space-time antenna, and this is the black one. And now we're going to see the first impulse. Probably this is going to be something like static electricity that is already inside, so it's going to be the higher. So let's see now, 47. Okay, 47. Now again 47. So you see now it's 37. And every time I touch it, slowly it goes down. 38 now, it shows a little bit more, 23, and now it's dropping a bit. Now probably I will touch it here in order to draw all the electricity, just to hold it and to see how until where we're going to drop. So now you see it's around 20 now. I'm holding it and you can see it's 4, it's 3, it's 4, it's not dropping, it's 5, 4, 3, 4, it's not dropping below 3, 2 for a second, but it shows that constantly there is some electrons moving inside. Still the red probe is not attached, but it shows that there is something going on, it's not dead. there is still movement inside. And I touch it again after and it shows 17. When I touch it again, it shows 16. It was 4 before. Now it's 10. You see, it's still, there is some life inside this coil. It's not like the other one completely dead. Now it was 13. You know, I wait a little bit. 11 again. Every time I touch it, it's like now 14. It's more than 10. This I didn't see with nothing else. Didn't see with the other coil. I didn't see with my antenna at home. I have construction now 23, I think was that, and 12 again. So I hold it again and drop until 2, but it holds. It didn't drop until 0. Now I wait a little bit and then I touch it again. 8. You see, this is very interesting because when I hold it, it was dropping until 2, now 12. And then I wait a little bit more and then I touch it again and the charge is more. Of course, we're working here with millivolts, something very, very little, but still the numbers are bigger. You know, this is what excites me. This is what I cannot understand. And if you are an electrician now, 15, you see, it's charging by itself. And this is just the first layer. Today I start to build a tetrahedron, which this device needs to be put. That's just the first layer. Now I'm holding the red probe with my hand, like a grounding, and I'm going to touch it. 27, you see, much more electricity inside, it's moving. Now, again, 9. Okay, you see 11. This is very interesting. When I hold the red probe with the hand, when I ground it, the electricity is much more. I leave it again in the air, it shows 14. I touch it again, 10. How this is possible? Why this is not happening with the other coil and with anything else that I try? Now I hold it again to drop until 2 and just to exhaust it, you know, just to drain it. I touch the other coil here and it shows 7, and then again I touch it and it's 1, 0. You see, it's nothing. Touch it again just to show you the difference. It's nothing, it's dead. But this one, when I touch it, it's 10. When I touch it again, it's like 7. There is much more life. Again 10. There is much more life, and still one of the probe it's not attached nowhere. In my hand now, 11. You see 9. It's some charge inside this. It shows that there are some electrons that they're moving inside. I'm super curious to see how this is going to behave when I encapsulate it with the tetrahedron. Guys, thank you for watching. If you have any questions, I will do my best to answer, and see you soon in the next video. Have a great day.